Hello and welcome to this next episode of Let's Play Gear City. Let's get cracking. We've got a chassis queued up. Oop, wrong button. Chassis queued up to design here, so it's going to take about 7 months. I was saying in the last video, a lot better than the truck chassis I designed. The overall 39 as opposed to 21 and a bit, and the unit cost, $60 per unit less, which is outstanding. Just to rub it in a little bit more, the design cost nearly 100 grand, 75 this time around. It's good to see I'm learning. So let's do an engine. Now we've been doing straight fours up till now because we use the assisted design. So let's see what we've got. So it's a 300cc straight four naturally aspirated, 4-stroke with 1 horsepower. It weighs 38 kilos. It's 10 by 8 inches, 88 miles to the gallon. The overall rating 29 and $100 in unit cost. So this time around, we're looking to increase all of those stats and aim for something a little bit better, and probably say a unit cost of say $120 to $130. I would say is probably a realistic one. So we're going to go a straight 3-cylinder. We're going to go a 2-stroker, so they're a little bit easier. We're going to go naturally aspirated. Now, I come up with a bit of an engine naming convention. So we go the fuel type, which is a 2-stroke. If it was a 4-stroke, we'd go 4. If it was a diesel, we'd go D. So we'll go 2-stroke, inline 3. And it is naturally aspirated, and it's the first iteration thereof, because we might want to do another iteration later on, change it to a 4-stroke or just update the engine. So we'll see if we can get this to about $120. Layout, performance, technology, design, and summary. No, we don't want summary. Okay, so our width for starters, so we can increase our length and our width remarkably. We can also increase our displacement up to, let's have a look here, chassis. What is our 26 by 26 is what we've got to play with here. But we're not going to want anything more than 4 or 5 horsepower, so we can actually drop this. Well, actually, we might do that another way. Fuel economy, engine torque. These are all dropping the unit cost, which is great. Unit cost, great, going down. So I'm just making this a little bit simpler. There we go, 108. We can also increase the weight, I would say. Well, that's not going to. Okay. Well, let's reduce the weight down as much as we can, and okay, so there's $112. Now what we'll do is we'll take a few more sliders and go for $130 unit cost. We'll see if we can get a little bit more power out of it. This thing is crap. It can barely power a bicycle, let alone a car. This motor is weak. In only but the smallest of vehicles, it would be a bad choice. Of course, as they always say, most people only buy the cheapest stuff, and this is pretty cheap, isn't it? Yes and no. I'd like it to be cheaper, but anyway. So, yeah, power. We need more power. So what we can do is we can increase the rotations of the engine, and that will steadily increase our power, but not at a rate that's most effective. Our fuel isn't bad. Where is it? Focus on performance. Okay, so that's bugger. I'm not getting the changes that I'd like. I'm just playing around with each of the, so that'll make it more reliable. Technology won't do anything to the stats. Neither will the manufacturing techniques. How to get the most power. I've tweaked something here, so it's not going all the way back. How to get the most power out of this engine. So that'll get it to 5 horsepower. There. 132. So that's 5 horsepower, 40 newton meters of torque, 23 miles per gallon. Let's compare it to what we have already in the engine 0. So this is, it's much bigger. It's got one less cylinder, but it is a 2-stroker. Power, it's got 5 horsepower as opposed to 1. It's got 10 more foot-pounds of torque. It'll do it at 3 or 200 more RPM. It weighs, holy shit, weighs a bit more. Holy moly. It's considerably larger. Our fuel mileage is much less. And as for the rest, well, we don't know until we design it. So let's see how we go. Build. Let's see how it stacks up. Yeah, so that's all better. All better. Power. Fuel economy is worth. Reliability a little bit better. Overall rating exactly the same. Bugger. So that design not as good as it could have been. So I'll probably, what I'll do in 3 months' time, I'll do another iteration of it and see if I can just improve upon these other numbers, and I'll just have to cop a a unit cost of say 140 or 150,000. Just 140 or 150 dollars per unit to try and get the overall rating up a little bit higher. Lastly, let's have a look at gearboxes. We've got a automatic 1-speed at the moment. It costs us $58 to do. Overall rating is 24. It's an okay thing, but we're going to do another one. So we want to keep moving forward as much as we can. We'll go on manual 4-speed, geared for generic, and I've come up with a naming convention for this as well. So it's going to be a manual 4-speed, geared for generic. It's the first iteration of. So we're going to go specifications, design, and summary. Now, gearboxes are fairly simple. The trick is getting them right. So technologies, where's that one? There it is. Design focus got that one. Specifications got that one. Okay. So what we have at the moment is a unit cost of 58. So we're going to take up to 80, say dollars unit cost. Let's crush all this down and just give us a bit of a starting point. Because I'm not sure. Yeah, being an automatic 1-speed, it's a fair bit cheaper. So, well, a manual 3-speed. Dear me, a manual 1-speed, $76. Oh no. So this gearbox is going to be fairly expensive. We'll go with a manual 3-speed. And what we'll do is we'll just actually design it as is and see how it goes. 41,000. That's not. That's not a huge amount of money. I'm making that in profit in 1 month. So let's compare it. Gearboxes, 3-speed manual, none of that. Geared for generic. Performance, fuel economy, power, reliability, overall 38. Jagged it. Ah dear. So there you go. A bog stocker. It's come in better than an auto, a 1-speed auto. And just to rub it in, look at that, half the design cost. So that's got 2 months to go. That means that we've got a fair bit of stuff come through. So a new chassis, a new engine that we're going to have to update, which is unfortunate, but we've nailed it with the chassis and the gearbox, which is great. Then what we'll do is we'll start updating some of these cars. We'll throw in, the better gearbox, for example, into the sedan, and we'll probably do the chassis as well, and leave the engine until we actually have an engine worthwhile putting into the car. So let's jump forward. 200,000, nice. So what we'll do is we'll just bank, say, 5 mil. Oh, we'll bank 4 mil. No, I'll do 5 deposit. Just remember, we've got to try and save some cash now. So we do have a war in about 8 years, 9 years coming up. No, less than that. Yeah, 8 years. 1912? Anyway, so expenditures, quite high. We're covering our R&D cost, 100 grand, 90 grand in distribution. Where are the others? Tax. So we copped 300 grand in tax right there. That sucks. So tax not there. That would be 500,000. So let's have a look at our sales. Yeah, sales are going alright. Our luxury sedan is going in the right direction. So is our compact, which is great. Everything else is just being sold. So let's jump forward again. 400,000. Interest gains. Research complete. So there's our gearbox done. All we need to do is wait for our chassis to be done, and then we can update our sedan. 300,000. Research complete. And there is our engine completed. Where's our chassis? Okay. Well, let's just check everything, make sure it's all going in the right direction. The compact is around the mark. See, at the moment we don't really have the the headroom. Oh, sorry, the production capacity to carry another branch. I'd really like to create another branch to sell these compact cars, but, well, actually, maybe we do. If we sell the compact and the luxury, that might give us enough. Let's have a look. Well, our luxury is doing really well in sales. It's making us nearly 100 grand, even though it's only selling 42 of them a month. It's actually selling as many as the Phaeton, and well, it's got a bigger profit margin, so that stands to reason. Revenue by vehicle. Obviously, our sedan, big seller, 300 grand. Let's have a look at something here. See, that factory cost is still huge. It's costing us $500 per unit that comes out of the factory in London to sell that. Whereas the New York ones, much less. Well, unless some of the branch cost is being counted in New York as factory costs. So, more research required. Let's jump forward another month. 100,000 that time, because we paid tons of tax. Let's have a look at the lobbyists and see what they're doing. I've saved you 1.3 million this year. There we go. So that's why we're doing this. The lobbying seems to be very effective. Let's have a look at the R&D department. We need to redo that engine. So design. Well, actually, let's have a look. Let's look at our old engine. So the two-stroke inline 3 naturally aspirated was pretty average, really. It didn't meet what we wanted because the overall rating was still low. So what we'll do is we'll do a second iteration of that, and we'll just see if we can. We'll see if we can lift the fuel economy. because that looks like it's really where it's falling down. Yeah, the miles per gallon. And even though it's a generic gearing, I think we can improve upon that somewhat. So let's modify. No, that's not what we want. 2 million. Whew, expensive. Better just to design another one. So it's a straight 3-cylinder. We can go up to 8 cylinders already. We can do a V8. We can do a U8. We can do a flat 8. We can do a H8. There you go. I dare say, well, I guess that as you go through the game, you get more and more cylinders. So 2-stroker, naturally aspirated. So we want it's going to be a 2-stroke inline 3 naturally aspirated revision 2. Okay. Let's bring up all of our okie dokie. So what we'll do is we'll just play around with a few things and see if we can get it to be roughly what we're after. Okay, 192, 152, 101, right. And that's with what it is there. Now, let's view this engine. Because we want to get the dimensions roughly the same, and then just go from there. It was 16 by 11. This is 14 by 11. So we can increase the length somewhat. And the displacement was larger. Now I don't think I'll get that anywhere near where it was before, but we'll see how we go. So the fuel mileage is now the same, so we need to try and lift that as much as we can. Width 16 by 11. Okay, so let's see if we'd increase our fuel economy. Well, there we go. We can get 30 miles to the gallon. Oh wow. 177. Ouch. Where'd our engine go? Here it is. Power. So I'd also increase the power somewhat to try and get it, to be a little bit better. So what we might do is also have a look at that, see if we can get it to 5 horsepower and what that's going to take us. So we'll increase the revolutions here to 5. Somewhere close to there. Oh. At 900 RPM. So that's costing us nearly $200 an engine. Oh dear. Conundrum. We need to get that down somehow. I'm not sure we can. Because that isn't a huge improvement over what we've already designed, but to get that overall rating up, we need to try and do something. Let's design it and see how we go.